I'd like to welcome everybody. This is Muddy Run Park, and my name is Ted Williams. We're at the official start time for our live event here at Muddy Run Park. And what I thought I could do today is, Dan, I need some technical assistance. There we go. No, I'm okay. I'd like to welcome you. My name's Ted Williams, and we're the Rittenhouse Astronomical Society. We're probably the oldest society in the country. If you go to our website and you see what you like, remember, tough times, everybody. We are running a business and we still pay insurance bills and web service bills. So if you ever like what you see, you're free to donate right there on our website. We provide this as a free public service, and we're the main education, let's say, group that provides the services here at Muddy Run. We have other astronomers who work with us from the Astronomy Enthusiasts of Lancaster County. And we also have the Hartford group with us from down in Maryland. So I'd like to welcome everybody here today. Kind of a special night. Usually in October, we have a big fall special. Exelon usually hosts it. They're doing an event here about once a year. And so although they're not doing that this year because of the virus, we thought we'd line up kind of a special night for you guys also. So we're going to divide this into a couple segments. You're going to see three things coming up. Denise Vecca will be with us, Mistress of the Universe, and she's going to do a little bit of a sky talk, updating everybody where the planets are. After that, I have the Philly Moonmen with us, and I'll talk about them before they come on their segment. They were out here, both of them recently, and have met Al Ryan and had some amazing questions they wanted to put together. So we thought this might be a really good night to interview Al. A lot of you know that Al is our observatory director, but many of you probably don't know his background or what brings him here also. And then after that, we have a really special night lined up for everybody. I'm glad to say we have Robert Noya with us. And those of you who are Rittenhouse members and you guys are tuning in or connecting the transmission, we had a great time with Robert. We did a talk with him a couple of weeks back with the Astronomy Society. And we had to get him here to Muddy Run because we wanted to get him into a bigger audience. And we know what's going on out here also. So, with all that said, Denise works in her own business, Stars on the Move. I met Denise back when she was working in the Fells Planetarium with me. And at that time, Denise was actually pretty influential in helping me with my master's degree. I'd like to turn it over to Denise. She's coming into us live, and happy birthday, Denise. Happy birthday to you. She's actually celebrating her birthday, and she's away on vacation, but of course, she loves what she does so much with us. This is her birthday night, and here she is. So Denise, take it away.
Well, thank you, Ted, and hi, everybody. Yeah, I'm in the Poconos, so if anybody is wondering where I am, and I have an observing spot that I go to, but it's not quite dark enough yet, so I'll go after dinner later on tonight and check out what I can see in the sky. But I'm going to tell you what you guys can see in the sky. So let me share my screen, and thanks for joining us tonight. And I'm doing this from my phone, so it might take a second or two. It won't be as flawless as a computer. And I'm going to start with a picture. This one right here. This is called the Witch Head Nebula. Ooh, I thought I'd share this since we're coming up on Halloween. And this is actually a nebula that it's very, very faint, but it is in the sky this time of year. And in the winter time, it's in the constellation of Orion by his ankle star Rigel. So the Witch Head Nebula, I don't know if you see it. You have to use your imagination a little bit, but there she is. And Halloween is also something interesting because it is actually a cross-quarter day. What is a cross-quarter day? It's the midpoint of the season. So you have the summer solstice, the winter solstice, the fall and spring equinoxes, but in between those dates, there's also cross-quarter days, and you may have heard of them. Groundhog Day is one of them on February 2nd, May Day, Lammas is like the celebration of the Harvest Festival in August, and Halloween, I think, is the most famous. So on this Halloween, we also have something special. We have a blue moon. So I don't know if I have a picture of a blue moon. No, I have a picture of Saturn, which I'll show you since we're going to see Saturn tonight. But yeah, the second full moon in a month is a blue moon. So we had one on the 1st of October, and now we're having one again on the 31st. And if I can zoom into this, I want to show you another moon. This is a moon of Saturn, and it's right in the middle of Saturn's rings, which I thought was really, really cool. I the name has just escaped me, so I'm going to forget about it. But Saturn has the most moons in the solar system. It's got well over like 84 moons now, more than Jupiter, and they are found within Saturn's rings, which may have been a moon. So I'm all about the moon. I love the Philly Moon Men, so that's kind of great that they're here tonight too. I know they love the moon. And we are seeing a sliver of a crescent moon. If you have a really good view of the horizon, you might see a sliver of a crescent. If not, wait until tomorrow. But if you're facing the west, you can also see Jupiter, and there's Saturn as well. Now, Jupiter is going to be brighter because it's bigger, it reflects more light, and it's a little bit closer than Saturn. Planets won't twinkle. That's how you know you're looking at a planet rather than a star, because stars twinkle the way they shine their light through our atmosphere, but planets reflect light, so they don't twinkle, and that's how you know you're looking at a planet. So as soon as the sun goes down over the next couple of nights, keep your eye on the moon. It's going to wax. It's going to look like it's getting bigger, and we're going to have that beautiful crescent until a week later. Then we'll have first quarter, and 2 weeks when we have Halloween, then we will have our blue moon. So if you face east, you can see Neptune. If you have a telescope, you're not going to see Neptune, chances are, with your naked eye. But if we look down here, we can see Mars. Now, Mars is great right now because it is close. It's within 40 million miles from the Earth. So that's as close as it's going to get. And it's at opposition, which means Earth and Mars are both on the opposite side of the sun. So it's up in our sky all night long. So Jupiter and Saturn will set by midnight, but you can observe Mars if you're out at the bar later on, or whatever you're doing, having a couple cocktails on your deck, and it's late and before you go to bed, 2 o'clock in the morning or whatever, you can still see Mars, but you won't be able to see Jupiter or Saturn at that time. So, get out early to see those guys. Now, the other thing you might want to look for is Venus, which is up early in the morning. So right before sunrise, if we let the program go, I also am using Sky Safari. And we can see there's Sirius, the brightest star in our night sky, and then Venus. So Venus and Sirius are going to be up in the morning. So Sirius will twinkle, Venus will not. So there are some fun things to look at in the sky all night long. So if you stay up all night like me, you can check out Venus in the morning, Jupiter and Saturn early, and Mars also all night long. I'm going to try and go back to Zoom. So I'm going to stop. Give me... Hopefully I come back to you guys. No, I don't want to start. There we are. I'm back. Yay.
You're there.
So there you go. So that's a little bit of an update on cross quarter days, what that are, and a little bit of a planet report. So hopefully you guys have clear skies tonight, and you'll get to see some of those beautiful things. Thanks.
Hey, thank you very much, Denise. It's always great, and thanks for making us part of your birthday celebration.
Oh, you're welcome. Thanks for celebrating with me.
I know you're this much into it. Can you believe, I think it's the last 7 years, I think I worked a planetarium show on my birthday night. And I sometimes think, it couldn't be better. It's already late. So thanks for sharing that personal time with us. It's
and
great.
If it is your birthday and you're into your sign, remember you can't see your sign in the sky during your birthday, because technically that's the sign that the sun was in when you were born. So that means your sign is actually up during the day, but that's kind of out the window too, because the earth wobbles, and when astrology was created, things have changed, and actually you're one sign behind what your astrological sign is. So your astronomical sign is technically what constellation the sun was really in when you were born. So I guess I'm a Virgo rather than a Libra.
Okay, well, thank you. Thanks for the update. And just to clarify, everybody, astrology is a pseudoscience, and astronomy is what we do here. But Denise taught me a lesson a long time ago, and she said, Ted, people have all different interests and all different backgrounds, and if I can touch a little astrology and at least bring them into reality, it just makes it all that much better. So thank you, Denise. Appreciate
You're
that.
welcome.
So it's interesting that we work at the Franklin Institute. I have to call everything kind of like BCV, before the COVID virus. So before the COVID virus, it was not uncommon to be up on the rooftop on weeknights, be out here at the observatory on Muddy Run on weekends. On those weeknights, Derek Pitts does night skies at the observatory. And it's always neat because I go up on the rooftop and I get to get away from the crowd, but the observatory tends to be like the big view that they want to get. And one night we're out there. I remember it being a pretty cold night, and someone had said, "Oh, you got to meet these guys, the Philly Moon Men. They're up here." And everyone looks around, and the two of them come over to me, and I'm introduced to Bill and Brendan. And I asked them a little bit about Philly Moon Men. What do you guys do? And they unveiled a story that sounded to me just like I had seen years ago with John Dobson. They told me that they are down on South Street. They're out there with a telescope, and they do this. They volunteer this view, and they entertain passerbys. They even said 4th and South, and I knew the corner because for years I had walked over that corner, and I had dreamed of bringing a telescope down there. Philadelphia changed. When I was younger, South Street was not an area I think you'd have a telescope on. And as things got much, much nicer along South Street, and once the nightlife picked up, these guys were a hit out there on the corner. I even went down and joined them. I had to do it because it was always a dream to be right there in the heart of Center City with the telescope. What I really liked was their approach. They wear a white jacket, and they had like a formal hello, and Brendan was very collegial with everybody out in the streets, and Bill was always jumping around trying to get some of the visuals and the stuff together. So I have them both with me tonight. They came to our astronomy society about a year back. You might have even heard them do some talks with us as they did a European tour, and they did observatories all across Europe. Well, they added us to their observatory tour. Both Bill and Brendan have been out to the observatory. They've played around with the telescope and been impressed with some of the views there. What I'd like to do is I'd like to turn it over to them tonight because they're going to talk a little bit about our observatory director, who they had the opportunity to meet with when they were here, and that was Al Ryan. So Al, if you move into the screen over there, and I think you're set, you can take your mask off if you'd like. And we can also, Bill and Brandon, I believe you're up and live. So.
All right. Al, good to see you again. The first time I was out at Muddy Run Observatory was about 2 months ago. That was where I met Al for the first time. I was so amazed at just the quality of the facilities out there. A little far flung from Philadelphia, but definitely worth the journey. You know, when I was out there that night, Al was tinkering away at a camera, trying to get some image stacking of Jupiter going. And what I did know about him is that he was the lead environmental lawyer at Exelon in his career, and he was responsible for so much of what I saw out there at Muddy Run. So we wanted to open this up to the whole group and get a chance to know Al a little bit and learn a little bit more about his storied life. So let's do it, Al. Are you ready?
I want you to know, Bill, I've taken the mask off, but that doesn't mean that the information is going to be any more forthcoming. So, what's your full disclosure? Some questions were given to me in advance. They went in one ear and out the other, so I'm not really prepared. So a lot of this is going to be off the cuff, so don't hold me to it. Okay.
So my first question for you, and you know, I also visited the observatory. It's very beautiful, and I was very impressed with the views that we were able to offer on your scopes. And I understand that you work for Exelon, and the facilities next to the observatory it's all part of a science outreach. And my first question is, how did Exelon, an energy company, get involved with astronomy? What was the connecting link between Exelon and astronomy?
Well, it was actually more straightforward than you think. It's an energy company because it operates a couple of energy facilities, and they're hydropower facilities. And in order to operate them, they need a license from the government, the Energy Commission. Part and parcel of a license is that you provide something back to the community. And typically what happens is an energy company will provide park, trails, canoeing facilities, boating facilities, that sort of thing. Somewhere along the line, someone discovered that there are fairly dark skies out here, and that expanding upon the recreational opportunities would be to take advantage of those dark skies. So that's where the idea of an observatory came to light to Exelon, and they said, well, okay, we don't need another canoe launch or another set of piers for fishing. We'll go ahead and we'll try this observatory concept. So they started with a simple star party. It was received very well. Upper management was very surprised and very pleased. And it was just a short leap from there to say, okay, why don't we give them a permanent structure? And a few years later, we have an observatory here.
It's really amazing. And, I know we're all so glad that they gave it a shot, and we're glad that, you had this idea and you've been sharing the skies. All right. The next question is going to come from Moonman Bill.
Yeah. So Al, it sounds like once Exelon decided they had something special going on there with astronomy at Muddy Run, it was sort of your knowledge and push that helped get the observatory off the ground. So can you help us understand, going back, what spurred that existing knowledge of astronomy? What got you originally interested in the night sky?
You want to talk about me? I thought you wanted to talk about the observatory. I can do this very quickly. I grew up along what's called a Space Coast. Used to be Cape Canaveral and Cape Kennedy, now Cape Canaveral again. And spent a lot of time watching rockets go off. At the same time, I was very much into explorations. I was reading about great explorers, Magellan, Da Gama, Henry the Navigator, all those people, and just sort of married the two together. Plus, I got hooked up into a gang of nerds who were into things like building telescopes and looking at the sky with them. So I did that in high school. I put it all aside for a few years, went away for college and later law school, and finally came back to it a little while later, just picking up bits and pieces and scraps of knowledge along the way. I joined the Chicago Astronomical Society and went into their mirror making class and made my telescope and started playing around again with it for a while, then put it away again. In the meantime, I got married, had a couple of kids, and my youngest daughter actually got very interested in astronomy, and she sort of piqued my interest again. And we just sort of went from there, acquiring telescopes, looking at objects, doing photography, that sort of thing. Reading a lot of magazines like Bob Sky and Telescope. And, I just picked up things from people I knew or met or read about along the way. And just when it came time to apply all that to Exelon, I just sort of threw it all at them. And they said, well, this guy really knows something, which I really don't. But, they thought so. And they figured, well, we'll take a chance. We'll have him be the lead on constructing this thing, and we'll see how far it goes. I got to throw a plug in here for Exelon because their main purpose was two main purposes. One was public outreach because it's in part a license requirement, but they're also very interested in this sort of cliched concept of giving back to the community. And they thought that providing a place where they could engage in STEM activities would be a very good thing to do for the community. So all of that came together with this structure we have here.
Right. It's very interesting to me that you kept finding reasons to take astronomy back off the shelf throughout your lifetime. And telescopes really are also a way of looking through a telescope is a way of exploring new frontiers all on its own.
Yeah, it's funny, that telescope I made back, I don't know, 30 years ago, I still carry it around because it was supposed to be a 2-3 week project, and I overground the mirror and ended up being like a 6-month project to get it figured perfectly again. So it's like a perfect mirror. It's only 4 inches, but it's a perfect mirror. And I carry it around, and every now and then I will take it out and just check it out to make sure it's still optically good.
An Al Ryan perfect mirror, everybody. Hey, I'll turn the next question over to Brendan.
Very good. I loved your personal story about how you found your passion for astronomy, and like Bill said, how you continue to pick it up throughout your life. So back to the observatory, there are a lot of wonderful components about it, whether it be the amphitheater outside of the domes or the equipment inside of the domes. And I'm just curious to know, what is your favorite thing about the Muddy Run Observatory?
Oh boy. Every time I come here, I find a different favorite thing, primarily because it's a different thing I'm working on. I really do enjoy the telescopes, especially the photographic telescope. I really like that one. It's an exceptional instrument, and a lot of quirky but really high-end equipment is hanging off the end of it. I really enjoy the amphitheater, just being out there in the open, having a focal point is just really kind of nice. And one thing we haven't mentioned is inside of our visitor center, which is also part of the observatory complex, we have this wonderful gallery filled with pictures. On one wall, there's a procession of planets, very large blow-ups. On the other walls, there are images of deep sky objects, some of which I think we've done better with our equipment, but and it's just wonderful. And when we do have the open houses, assuming they'll come back again, we get this remarkable group of people who know all about it, and not just know about all of these things in the solar system and in the heavens, but they're able to impart that information to people of all ages. And it's just really kind of nice to watch, you know, from the little kids with their wow to the older grandparents bringing them in with their wow. So, I really enjoy that part of it as well. So.
Yeah, it is a very beautiful observatory. It's one of the finest that we've ever visited. And like Ted said, we did a little astronomy tour visiting different observatories around Europe. And of course, the outreach that you do with all of these fine tools is just fantastic. So it's great to hear about how that's been going. And the next question is kind of about a little bit about on this subject. So I'm going to hand that over to Bill.
Yeah, so we touched a little bit about it when Ted talked about BCV, before COVID virus. Al, I want to know, what do you think will happen ACV? After we are able to open back up for more outreach activities, and where do you think the future of astronomy outreach is going at Muddy Run?
Well, that's something we're thinking about right now. I think we'll come back with the things we have been doing, that is the open houses with masses of people coming in and being educated, having lectures either inside or outside, depending on weather conditions, bringing people in who know a lot more about a specific subject than any of us do. But we're also starting to develop an expertise in this electronic assisted astronomy. So one of the things we're planning on doing in the near post-COVID period, when we're still limited with the number of people we can have, we're going to have the amphitheater set up so that the image from the telescope is beamed to the big 24-foot screen. That way we don't have people trying to contaminate eyepieces all night long and trying to clean them and everything. We're going to have that there. But in addition, in order for people to be able to separate themselves and not be bunched right in the middle watching this screen, we're going to have 2 other screens at different parts of the park with people with telescopes pointing at different objects so that people can walk around, go from one object to another, get some education about, oh, that's what the Ring Nebula is like. Okay. Oh, that's what the double cluster is. So that they'll be able to sort of go around and have a more circular experience rather than just walking into the telescope, getting a 30-second view and hiking down the ladder again. So we're hoping to sort of broaden the experiences people will have here. So that's kind of like the near post-COVID to the post-COVID thinking that we're engaged in right now.
It sounds like Muddy Run will have its very own version of some sidewalk astronomy down that hill.
Well, it will. And there's one other thing that we're doing. I'm a little reluctant to mention it, but I will. In the spring, we're planning on opening up a 3rd observation area. Right now we have 2 14-inch telescopes, 1 in each dome. We're going to have a 3rd telescope that is in the form of a binocular telescope, and it will have 2 25-inch mirrors. We're not quite sure how we're going to do the people shuffling with that yet. And we haven't really nailed down exactly what the building's going to look like, but it's coming together. And, it's just all part of that giving back to the community that the company is engaged in.
2 25-inch mirrors in a binocular telescope. You might want to tell the folks at Mauna Kea that you're competing with them.
Well, no, it's not that large, but to give some perspective, I think one of the numbers that we ran indicated that you could see a dime from 7 miles away with this telescope. So
wow.
We'll see. And you're able to peer back pretty far into the universe. And I'm not quite sure I want to say this because Bob Noya will correct me in a minute, but I think we're able to go back about 2/3 of the age of the universe with this scope. That's the light gathering power it'll enable us to.
Yes, that's right. I mean, that's
Really
my favorite
incredible.
part about telescopes, right? To say that they are also time machines once they get big enough. So I think we have time for just one more quick question. So I'll turn that over to you, Brendan.
We definitely have a lot to look forward to with your plans for the reopening. And your that's just really exciting. So as the final question, I'd like to give you a chance to reminisce on your proudest moment or most favorite moment at the observatory, whether it's capturing a faraway galaxy for the first time, or maybe a night that you did some outreach. So I'd love to know what that is.
Well, I knew this question was coming and I was hoping that you wouldn't ask it because generally don't have any proud moments.
Sorry.
But I'll tell you one thing that was pleasing to me is one of our fellow astronomers here from Harford County, Larry Hubble, no relation to Edmund Hubble, by the way, but he and I have been working on the photographic telescope for a long time. And there was one period where everything worked perfectly. And we got 9 or 10 hours of light, different wavelengths. We're using narrowband filters. And we got a gorgeous image of the Eagle Nebula. And that was probably one of the more pleasing things that happened with this observatory because it just proved to us that it has really great potential. And we just have to tap
Absolutely.
better than we do now. So
Incredible moment. So definitely looking forward to what's to come. So Al, just want to thank you for coming out and letting us ask you these questions tonight. It was really great to get to know more about you and how this all got started. So thanks again.
well, thank you.
Hey.
It's great that the Philly Moon men and Moon women, I hope, are engaged with us, and we hope to do a lot more together in the future. Okay.
Hey, thanks, guys. Hey, you helped
Thank you,
me
Al.
learn a little bit more about Al, too. And I've been working with him for some 9, maybe 10 years. Thank you very much, gentlemen. Oh, by the way, and just so you know, Al's going to be lending you a small camera. It's a Revolution camera. Might get you started with some video astronomy. And while it has a little bit difficulty with stars, it gives a great view of the moon. So you might want to play around with that. Next time we get together, I'll pass that off to you. Okay, thank you, gentlemen. Thank you very much. I see him out there on the Zoom. Robert Noy is with us tonight. This is a long-term affair with Robert. This is almost, I think it might have been 3 years back that we were recommended that he's a very entertaining speaker. And we're always looking for somebody who can have a wide appeal to a big audience. And we were at the Franklin Institute at the time, and we asked him to come down and do a talk at I believe he was in the Fells Planetarium with us also. And it was amazing. He was very entertaining. He's a very lively gentleman. He was the editor-in-chief, I believe, of Sky and Telescope, and he's been an editor with Astronomy Magazine also. And what's kind of interesting is he has published an article recently. It's in the Astronomy Magazine, but I think we're a month or two back right now for that one. And it was all about exploring for life out there in the universe somewhere. So I've enjoyed this, and Robert says he's actually updated the talk. So if you're a Rittenhouse member and you're tuning in, hey, really pay attention, because a lot of developments happened even in the couple of weeks since he gave the talk. So I'll get quiet, and ladies and gentlemen, it's my pleasure to bring this gentleman out here to Muddy Run Observatories with us, Mr. Robert Noy.
Okay, here we go. I think we're good to go, right? Okay, great. So, just first of all, I want to thank Al, Ryan, and Ted for inviting me to speak to you tonight and for setting all this up on Zoom. And I want to thank the Muddy Run Observatory, Exelon, and all the volunteers for the different clubs and everything they do to maintain this great institution. I've had an opportunity to visit it several times, and it's just a really wonderful place. And it's a nice evening out there where I am, right outside Hershey, Pennsylvania. So I appreciate all of you for tuning in tonight to hear this presentation. So I have a lot of ground to cover. I want to save time for Q&A, so I'm going to dive right in. So my talk tonight is based on a cover story I wrote, and Ted was right. It's a couple months back, September 2020 issue of Astronomy Magazine. I also wrote a accompanied web article as well. So if you find tonight's talk interesting and you want more info, check them out. So my talk tonight is based on, is about scientists searching for life on other worlds. And of course, that raises questions about, the prevalence and nature of extraterrestrial life. And scientists have discussed these topics for centuries. The public is interested too. Look at the popularity of E.T., Star Wars, Star Trek, any movie, Avatar, any movie that portrays alien creatures seems to be a big box office hit. But despite all this, speculation and interest, astrobiology is really a science whose subject matter has not been proven to exist. So we need to turn astrobiology into an observational science. That means we need to look and find out what is out there. We really don't know what's out there. Now, there are reasons to be optimistic that there's life out there. For example, geologists have found chemical evidence in the form of carbon isotope ratios in very ancient rocks, like the one we see here in Greenland, which dates back about 3.8 billion years. And that evidence points to that there was life on Earth not long after the planet formed. There's actually fossil evidence of fossil life dating back 3.5 billion years. So life got started early on Earth, which indicates but does not prove that life will get started anywhere conditions are right. Meaning, you've got liquid water, organic molecules, and flows of energy. Another reason for optimism is just think about our galaxy, the Milky Way. We've got about 200 billion stars, give or take a couple hundred billion. It's a lot of stars. We know that a lot of them have planets, and those planets have a lot of moons. So there could be, like, if you include planets and moons, the numbers in the trillions of worlds in our galaxy alone. And then, I'm sure all of you have seen the Orion Nebula Naked Eye Binoculars Telescope. That's where stars and planets form inside these interstellar molecular clouds. And they're just loaded with carbon, oxygen, nitrogen, hydrogen, phosphorus, all the elements we associate with life on Earth are very, very common throughout the universe and throughout the galaxy. So that's a good sign too. But I would argue that it's really dangerous to draw firm conclusions from just one example of a phenomenon. For example, it could very well be that the origin of life on Earth was a once in a universe miracle that's never been repeated elsewhere. It might be that we're incredibly lucky that life has endured for billions of years on our planet as it has undergone profound transformations in terms of temperatures and climate, atmospheric constituents, et cetera, et cetera. And maybe it was just a fluke that life evolved from very simple one-cell bacteria and microbes into multicellular life and ultimately into very complex plants and animals. So I would argue that we can't really answer these deep questions by just studying life here on our own planet. We really don't know if Earth is typical or atypical. So as my astronomy article explains, we need to go out and look. And scientists are kind of taking 3 different routes or roads to detecting extraterrestrial life. So the first one I'll talk about is exploring our solar system. The second one is probing the atmospheres of planets orbiting other stars known as exoplanets. And then the third road is looking for signatures, what I will call technosignatures of other advanced civilizations. Now, I talk about these 3 approaches. They're not really competing. It's just different ways astronomers are looking. It's not a race or a competition. We don't know which avenue is going to be the most productive. We don't know how common life is. So it's impossible to predict how easy or hard it will be to discover, or who will discover it or when. What I can say, though, and this is what gives me some optimism, is that our technology keeps getting better and better. So I would say I'm 57. I'm optimistic it'll happen in my lifetime, maybe in the next 10 or 20 years, but we really don't know. Could be sooner than that even. So the next important question is, what is it that we're looking for? And this is kind of interesting, as I read books and articles about astrobiology, there's no set agreed upon definition for what life is. And on Earth, we see an incredible variety of life. Like when you think about microbes can exist in like acidic hot springs at Yellowstone National Park. It can exist in cold and dry valleys in Antarctica. It can exist over a mile underground in the pores of rocks, and it can exist at the bottom of the ocean in crushing pressures. And then if you look here on this slide, we have more complex life. We see plants and animals, take an incredible variety of forms, filling many, many different environmental niches. So when we think about life on other worlds, that's a huge unknown. There could be life-supporting environments on other worlds that are totally unlike anything we have on Earth. So scientists need to be broad-minded in their thinking about extraterrestrial life. So, given our ignorance of all the different forms of life that can be out there, we can't really resolve any of these really interesting questions about extraterrestrial life through calculations or theoretical speculation. We don't know who or what is out there. We don't know how common life is. So we need to observe and explore. So that's what I'll be talking about for about the next half hour. Now, some of you might be thinking, well, didn't scientists just a few weeks ago announce the discovery of life on Venus? So in mid-September, and I bet you all of you heard about this, an international team of astronomers announced that it used 2 different radio telescopes, one in Hawaii, one in Chile, to detect the molecule phosphine in Venus's thick atmosphere. So phosphine is a molecule, consists of 1 atom of phosphorus and 3 of hydrogen. So this slide here shows the spectrum. It's actually in rate, or actually technically sub-millimeter waves. Think of it as like very short wavelength radio of radio emission coming from Venus, and some of that radio emission is being blocked or absorbed by phosphine molecules in the atmosphere of Venus. So you can see there's 2 different telescopes, James Clerk Maxwell in white, the ALMA in Chile in blue. So these dips come from light being absorbed by phosphine in the atmosphere. But I need to emphasize that the team did not claim that it had detected life on Venus. Now, Earth does have trace levels of phosphine in its atmosphere, and it comes from life. Most of it comes from microbial life. A small part of it comes from human industrial activity. So what the team did was it said, we've detected phosphine. We've researched all the different ways we think that phosphine could be produced on Venus non-biologically, and we can't think of any way to do it. So that leaves life as a plausible explanation. Now, the phosphine is in a layer about 30 to 40 meters or 30 to 40 miles above the surface. It's an area that has mild temperatures and pressures. And scientists have actually been speculating that this layer could have life. This actually goes back to Carl Sagan in the 60s. On the other side of the equation, though, the clouds at that layer are made of sulfuric acid. That's pretty nasty stuff. And there's no water. So if there are microbes kind of circulating up and down in the atmosphere in that zone, it's life very different from what we have here on Earth. And I would just argue, Venus is a hellish planet, 900-degree Fahrenheit surface temperature, crushing pressures. It's a hellish planet. I don't dismiss this possibility, but, I remain kind of skeptical. And, to really take this to the next level, we're not going to be able to resolve this question, by observing Venus from Earth. We're going to have to send some kind of air, craft or balloon that can float in the atmosphere, sample material in the atmosphere, and see if there's life there. So I now want to next turn to the rest of the solar system, and I'm going to start off with Mars, which, as you all know, periodically comes close to Earth as it is right now. That makes it relatively easy to observe by both amateur and professional astronomers, and relatively easy for spacecraft to get there. So here we see, by the way, a beautiful amateur image taken just a few days ago by Damien Peach in England. Now, for very long stretches of history, many people assumed that Mars was inhabited either by abundant vegetation or even intelligent beings. People thought there was a civilization there, inspiring a lot of science fiction by H.G. Wells, Ray Bradbury, and others. But NASA spacecraft that flew by and then went into orbit in the late 60s and early 70s disabused humanity of those notions. They showed Venus's surface to be cold, dry, barren, no obvious signs of life. But the orbital photos did some really great things. They revealed, and you can see in these two Viking pictures, channels across the surface, mostly kind of near the equator, that look very much like dried up, river deltas here on Earth. And ground exploration since then by NASA landers and rovers has proven that, yes, these were carved by liquid water billions of years ago, meaning that Mars, in its very early history, had warmer and wetter climates very much conducive to life. So this raises questions. Was Mars ever inhabited in its distant past? And if so, has life managed to survive to the present day? And now in 1976, NASA sent two landers, Vikings 1 and 2, and they became the first spacecraft to successfully land on Mars after several failed Soviet attempts. On the left is a model of a Viking lander, kind of like the size of maybe a little smaller than a small automobile. And on the right, we see a nice image from Viking 1 with my favorite rock on Mars, Big Joe. Now, if the lander had come down on top of Big Joe, then it would have been my least favorite rock on Mars. So both Viking landers carried mechanical arms. They scooped up the sand on Mars, brought it inside the lander. They conducted 3 separate experiments to look for signs of metabolic activity, where you expose these Martian dirt samples to water and nutrients and see if there's microbes that convert that into gas. And what's really interesting is that one of the 3 experiments at both Viking 1 and Viking 2 sites, which were 4,000 miles apart, basically on opposite sides of the planet, that experiment, and they did a series of experiments with that instrument, came up positive. It gave the exact results you would expect if there's life on Mars. But because the lander didn't find evidence of organic compounds, most but not all scientists interpreted that positive result not as life, but as an active chemical agent in the soil. But I need to really emphasize that this is an open question. It is certainly possible that Viking did detect life on Mars all the way back in 1976. I find it really unfortunate that NASA has not sent a rover or lander to Mars since to really follow up on that result. It really has not. NASA will I think has been somewhat misleading to the public. They really haven't followed up Viking with a life detection instrument. Their main interest is follow the water, try to understand more the history of Mars, more than looking for life. And I find that kind of unfortunate. And I'm sure many of you might remember this. Anybody who's probably, was following astronomy back in the mid 90s remembers when there was a big press conference of NASA and Stanford University scientists, even President Bill Clinton at the time. And by the way, this is the only time politics is going to be in this talk. But there's a big announcement about that they found evidence of ancient Martian life inside a meteorite that was called ALH 84001. You can see it on the left. This was a meteorite that we can definitely say was from Mars because it has trapped atmospheric gases that match that of Mars's atmosphere. And this rock is very old. It's like over 3 billion years old. They found certain chemical signatures that on Earth can be produced by life. And on the right, you see this tiny little worm-like thing that was interpreted as a possible nanobacteria. So these results remain controversial because everything that the Stanford and NASA team pointed to as being indicative of life, you can produce through geological or chemical processes. So I would argue that this result's still hanging out there, could be life, might not be life. But if it is life, it's life long, long ago. And much more recently, both telescopic and observations from NASA's Curiosity rover, which is on Mars and operating right now, have detected the organic gas methane, CH4, in trace amounts in Mars's atmosphere. And more recently, Curiosity has detected oxygen, same kind of oxygen we have in Earth's atmosphere, on Mars. They're in very slow levels, but they rise and fall with the seasons. The detections seem pretty robust. Now on Earth, both methane and oxygen, almost all of it that's in Earth's atmosphere is biologically produced. Especially oxygen is from photosynthesis, or almost all the oxygen. So this is really tantalizing, not proof, because you can still produce oxygen and methane, with processes other than biology. But, from my point of view, that's pretty interesting. And, that might be telling us that there's life on Mars right now. And then you combine that with the Viking results, who knows? So a few months ago, July 30th, NASA launched its next Mars rover called Perseverance. And the scientists on the team call it Percy. So I'll just call it Percy. And here we see a really nice artist rendition of Percy operating on Mars's surface. So Percy is going to land, or hopefully land and not crash. Probably it'll land. NASA's getting pretty good at this, in Jezero crater on February 18th of next year. So it's going to touch down in this area. This is a color-coded orbital image, and it is what it looks like. This is an ancient river delta on Mars. So Percy's going to encounter a lot of rocks that either formed or were inside flowing water long, long ago. So Percy isn't really carrying a specific life detection experiment, but it can do mineralogy, and it's conceivable that it could detect minerals that would form in the presence of life. So it is possible it'll find evidence for life, but more important, it's going to collect rock and soil samples for later return to Earth. So NASA and the European Space Agency are planning a very ambitious mission to return samples from Mars in the early 2030s. And in the words of Percy science team mission Jim Bell, who's a brilliant scientist at Arizona State University, his view is the rover's mission is not complete until these samples that it collects are brought back to Earth. So NASA is going to provide the fetch vehicle, and then it's going to send them to this rocket, launch it off Mars. The Europeans then are going to send a vehicle to rendezvous all robotically in Mars orbit, collect that fetch vehicle, and then return it to Earth. So this is going to be an extremely ambitious and challenging mission technologically. But if NASA and the Europeans are able to pull it off, we might be able to answer the life question. We might find either fossilized evidence or actual living microbes in these samples brought back to Earth. We'll have to wait and see. Now, the Europeans are planning their own mission called Rosalind Franklin. And she was, and I wish more people knew who she was. She was a brilliant British scientist who did cutting edge work in a lot of different fields during the 1950s. And one of the things she did is she did the X-ray imaging that Watson and Crick, who stole her data without her permission, they then used her data to show that DNA is a double helix in structure. They later won the Nobel Prize. She had died young of cancer. And in his book, The Double Helix, Watson dissed her. Like he needed her data to make his discovery, and she was dead, didn't have a way to defend himself. It's really a disgrace. I actually find him a disgrace, even though he made a great discovery. The good news is her reputation now is secure. Everyone who's in that field knows who she was. And the Europeans are naming this rover after her. And I think that's a great thing. Now, originally it was going to launch earlier this year, but there were problems in the testing with the parachutes. And then they hit the COVID crisis. So the launch has been postponed for the next launch window toward the latter half of 2022. And then it'll land sometime in the first half of 2023. So this rover is going to be able to drill down 2 meters, scoop up samples. It's going to be crushed into a powder and heated. And then this is what's cool. They're going to look for organic molecules and biosignatures of past or current life. So if Mars has life, especially right now, it's possible the Europeans could beat NASA to the punch. And I'm wearing my NASA shirt, but NASA will have a lot of egg on its face if they've been launching all these landers and rovers, but it's Europeans who prove that there's life there. Now, if these missions cannot resolve the life question, doesn't mean there's life on there's no life on Mars. It just might mean it's hard to find. So it might require future human explorers who can dig down maybe into hydrothermal areas underground or aquifers or other locations that are most likely to harbor life. So it might require a sustained human exploration over many years to really determine if Mars is a living or dead planet. And by the way, I love this artwork because it shows children along with the adults. Now, finding evidence of life on Mars, and I don't think it's going to be like a plant like we see here, but I like this art here, but it's going to be an incredible discovery because if you can do an analysis of that life, one of two possibilities. Let's say there's clearly an evolutionary linkage to terrestrial life. For example, let's say it uses DNA to encode genetic information. That would imply that life originated either on Mars or on Earth and was transported to the other planet inside a meteorite like ALH 84001, or that both planets were seeded from a common outside source. But let's say the two forms of life are totally different. That would imply that life originated independently on both planets. Now you have two separate planets orbiting the same star, each originated life independently. That would be very compelling evidence that life will get started anytime you've got the right kind of conditions. I think that would be telling us there's billions of inhabited worlds inside just our galaxy alone. So I want to now move to the outer solar system, and there's a number of different worlds that could harbor life, but I'm going to really focus on just one of them tonight, and that's Europa, because that's one where we have, a mission that, that's the one we're most likely to resolve the question, maybe in my lifetime. So Europa, we see it here on the left, and it's also arrowed on the right compared to the other three large moons of Jupiter called the Galilean moons, also compared in size to Earth and our moon. You can see it's a little bit smaller than our moon. So NASA flew by two spacecraft, Voyagers 1 and 2, back like 1979 and 80. They were able to measure the bulk density, and the density of Europa indicates that there's a water layer underneath the surface. The surface is like very hard, cold water ice, but there appears to be a liquid water layer below it. And you can see that Europa is crisscrossed with these dark streaks. That indicates that material from that ocean is kind of dredging up and getting to the surface. Now, here's a much higher resolution image from NASA's Galileo spacecraft, which orbited Jupiter from 1995 to 2003. And it flew by Europa at close range multiple times and took really spectacular detailed images like this one. And you can see that it looks like the surface, remember, this is all water ice, is kind of broken up into these ice rafts that appear to be floating on a liquid medium below. Galileo also discovered that Europa has a magnetic field, which indicates that this ocean below the surface has a lot of salt in it, just like Earth's oceans. And even more intriguing is that Galileo carried spectrometers and detected the signature of organic material on the surface. So, and since then, Hubble Space Telescope data and archival data from Galileo have shown evidence that Europa is shooting water-rich plumes into space. So there is abundant evidence, I would say virtual proof, that Europa has a thick layer under the surface of water, liquid water, and the models indicate there's more water in this ocean than all the water in all of Earth's oceans combined. And this water is probably in contact with a rocky layer below it, just like Earth. And Europa is also tidally heated from being gravitationally tugged by Jupiter and the 3 other large moons. So Europa has all the ingredients for life as we know it: liquid water, organic molecules, and energy. We're not talking some exotic alien life form. There could be life on Europa that's very similar to life on Earth. And you could imagine hydrothermal vents on Europa, just like the ones we have at the surface or at the seafloor on Earth. And those hydrothermal vents are amazing environments. They power, these vents are rich in nutrients, and it fuels these very rich ecosystems, lots of different types of creatures in complete absence of sunlight. So you don't need light from the sun to have life. So, this is a really interesting world. So NASA is planning to send a mission to Europa that's going to launch later this decade, arrive in the early 2030s, called Europa Clipper. Now, Europa Clipper is a Jupiter orbiter, but it will be put in an orbit that will enable it to fly by Europa multiple times. I think the plan are 44 flybys, some at very close distance. It's going to image the entire surface at high resolution by seeing how it's tugged by the gravity of Europa. They'll be able to get an indication how thick the ice is and where the ice might be at its thinnest. It'll be able to get better spectra of the surface and also fly through these watery plumes and measure the composition. So it might not be able to actually detect life, but it will pave the way for a future lander that could either melt through this ice layer or drill through it and deploy some kind of submersible in the ocean that could look for signs of life. Now, this mission's probably, 10 or at least 20 years off. Not sure if it'll happen in my lifetime, but, this is really going to be an amazing mission. And I mentioned this a couple minutes ago. There's other moons in the outer solar system, like Enceladus and Titan, are moons of Saturn that might also, have life. Or those are moons of Saturn. So, there's a lot of possibilities in the outer solar system for life. So I don't want to dwell too long. I want to move on. So it's time to leave our solar system behind. And now I'm going to talk about planets orbiting other stars, which are known as exoplanets. So as of today, and I checked just a few hours ago, astronomers have found 4,362 exoplanets, and that's 545 times as many planets as we have found orbiting the sun. And we can tell from doing statistics on the discovered planets, there's an average of at least one planet per star. So we're talking hundreds of billions of planets in our galaxy. But as I think you all know, stars are very far apart. So the closest exoplanet is 4.2 light years away. That's 25 trillion miles. So we're not going to be visiting these planets anytime soon. So you might be wondering, how can we study them for signs of life? So this movie, and I'm always a little nervous putting movies in PowerPoints because sometimes they don't work, but this one seems to be working, so that's good. So the easiest planets to study are those that orbit, whose orbits around their star line up with Earth, with our line of sight, so that every time the planet goes around its star, it crosses the star's face as seen from Earth. So that's called a transit. So when the transit happens, you can see the light curve below. You get a small dip in the observed light from the star. So by seeing multiple planet or transits occurring periodically, that tells us that there's a planet there. In fact, most of those 4,000 plus planets were discovered through this transit method. Now, here's an illustration of light. Some of the light from the star will pass through the upper atmosphere of the planet. So the atmosphere will absorb or block some of that light and cause the light from the star to be fainter at a specific wavelength. So here's sort of a diagram of how that happens. And that you can see that in the spectrum. You get a dip at specific wavelengths, and that's characteristic. It's like a fingerprint identifying the element or molecule in the atmosphere. So some of these spectral lines could be indicators of life. Those are known as biosignatures. So here we see the spectra of Venus, Earth, and Mars as an alien astronomer might observe them from, let's say, 20, 30 light years away with a very advanced telescope. You know, the thing that would immediately jump out to them is Earth. They would see the dip there for O3. That's an oxygen molecule with 3 atoms called ozone. I'm sure all of you have heard of the ozone layer. They would see that line and they would say, oh my gosh, this planet has a lot of oxygen in its atmosphere. Oxygen's a very reactive chemical. If it were not being constantly replenished by photosynthesis, it would disappear from Earth's atmosphere in just a few hundred years. There's also, they would see the water vapor and the carbon dioxide. They would immediately think of Earth, very high probability there's life on that planet, and probably very abundant life. In contrast, they would look at Venus and Mars. They would see basically it's almost all carbon dioxide. There's so many different ways to produce CO2 that does not involve life. They would say Venus and Mars, we're not that interested, but we're really interested in Earth. Of course, they'd have a different name for these planets. Who knows what they'd call us? So, you know, astronomers are going to be taking spectra of Earth-sized exoplanets and looking for these chemical signatures, such as oxygen and water vapor. And they're going to be particularly interested in planets that orbit within the habitable zones of their stars. Those are planets that are the kind of a Goldilocks zone, the right distance from the star, where you get just enough heat and energy from the star that water can exist as liquid on a planet's surface. And you can see here how the size and location of the habitable zone depends on the star, on how much energy the star is putting out. Astronomers will also be looking for things like chemical disequilibrium, where you have different chemicals in the atmosphere of a planet that shouldn't really coexist together, like two chemicals that would sort of destroy each other. So if you see them together in an atmosphere, it means something is constantly replenishing them. And certain chemicals like methane and oxygen would be very, very encouraging of life. So astronomers have already used this transit method to discover dozens of chemicals in exoplanet atmospheres, such as water vapor and carbon dioxide, but they think that they're going to need bigger and better telescopes to really find biosignatures, which might be, you know, kind of more difficult to detect. So the good news is that these next generation telescopes are right around the corner, the first of which around this time next year, NASA is going to be launching the James Webb Space Telescope, an infrared telescope with a much bigger mirror than Hubble's mirror. It's going to collect more light so it can be sensitive to fainter objects. So it's going to be, looking for infrared signatures, and it could detect things like water, ozone, methane, and CO2 in exoplanet atmospheres. Now, international consortiums are working on gigantic land-based telescopes pictured here. These are all expected to come online in the second half of this decade. We have the 30-meter telescope in Hawaii, the Giant Magellan telescope in Chile, and the European Extremely Large Telescope in Chile. Imagine that, a 40-meter telescope. So these dwarf all current ground-based telescopes. They're going to be equipped with absolute state-of-the-art spectrometers and instruments. So they're going to be able to actually probe more transiting exoplanets than JWST will be, and with actually better spectral resolution. Now, because they're on Earth's surface, they're going to be really optimized for visible light, the light we see with our eyes. So they're going to be able to really be good at seeing oxygen, both O2 and O3, and water. So I think that if life is common in our galaxy, one or more of these telescopes will start finding it. Now, the astronomers also on the drawing board are working on future telescopes that are really optimized for exoplanet studies. And the one I think I really like is this one called ExoLife Finder, or ELF. This one will have an advanced instrument called a coronagraph that can blot out the light of the star. Now, the star is going to outshine its planets by about 1,000,000 to 1. So if you blot out the light of the star, it makes it much easier to observe the planet, and you open this up to planets that don't transit their stars. And that's going to be the large majority of planets are not in an alignment where we see them transit from Earth. So this telescope has amazing capabilities if it ever gets built. It'll be able to detect all sorts of biosignatures in atmospheres. It'll even be able to image the surface and clouds in the atmosphere. That's very, very powerful. And maybe someday astronomers would love to build a giant space telescope that's optimized for exoplanet studies. So the one that's on the drawing board right now is called LUVOIR. It's going to launch in the late 2030s. This will even be bigger than the James Webb Space Telescope. If there's like any planets within maybe a couple dozen light years of Earth with life that's detectable, LUVOIR would be able to detect it. It'll be very, very powerful for these exoplanet studies. So I now want to reach the final part of my talk, which is the search for extraterrestrial intelligence, or SETI. But I'm also going to talk about technosignatures, which are signs of an advanced civilization that is modifying its planet or its environment in some way that our telescopes could detect. And I think, as many of you know, since the early 60s, astronomers have been using radio telescopes and arrays such as the Allen Telescope Array in California to search for radio signals from other civilizations. But I really want to emphasize, and I don't think this is something a lot of people in the public know, SETI is only a very minor part of what radio astronomers do. Most of their observations involve known objects such as stars and galaxies. So the most advanced SETI project right now is called Breakthrough Listen, funded very generously by this tech billionaire at the upper left named Yuri Milner. And it's using these two large radio telescopes, one in West Virginia, the other in Australia, to listen for signals from other civilizations. Just a few months ago, this project released data on 300,000 stars, And this and other SETI projects are ongoing. They're getting more and more sophisticated, better equipment. So far, no clear-cut alien signals, but if there are radio transmitting civilizations in our galaxy, sooner or later, it's possible one of these projects will hit the jackpot. There are also several groups, including Breakthrough Listen, that are searching for powerful laser signals that could be transmitted by other civilizations. This is known as optical SETI. The leading group right now is led by Shelley Wright at the University of California at San Diego. Her group is working on a telescope and an equipment that can do an all-sky survey for pulsed laser signals that only last for about a billionth of a second or shorter. Nature doesn't produce signals like that, so that would be a clear sign of artificial origin. Now, if we are going to discover other civilizations, though, I'm going to put my money on an accidental discovery of a technosignature. That means that there could be advanced civilizations out there that are engaging in these very advanced astroengineering projects. And someday our telescopes might be able to detect that. Like, here's an example of a space colony that's orbiting a black hole. Now, we're a long way from being able to do this, but who's to say that a civilization that's been around for millions of years, maybe has developed very high-level artificial intelligence, wouldn't be capable of doing this? We really don't know. So when we think about technosignatures, it's speculative, but I find it really interesting because it's forcing us to think about what might civilizations be doing that are millions of years more advanced than us. So think about the Pilgrims who 400 years ago landed at Plymouth in Massachusetts. How could they couldn't imagine like anything that we're doing today. If you were time traveled back then and tried to tell them what we'd be doing in 400 years, they would burn you at the stake. So it's really a lot of speculation. So here's, there's a number of different ways that we could discover this. For example, a few minutes ago, I showed you that image of the Exolife Finder, ELF. If there's civilizations within a few dozen light years that are polluting their atmosphere with chlorofluorocarbons as we do, that, ELF could detect that spectral signature. And then one of the team members, Jeff Kuhn at the University of Hawaii, he said we could image planets, the thermal emission of cities on other planets. So, for example, another civilization, maybe 20, 30 light years away, it has ELF. It could detect the night Philadelphia at night by detecting Philadelphia's heat signature. So who knows what those cities would look like? This is a wonderful piece of space art. Another idea is they're called Dyson spheres, from the physicist Freeman Dyson, who has spoken at Muddy Run. He died earlier this year at the age of, I think he was 97. Now, he didn't come up with the idea, but he popularized the idea that a very advanced civilization could disassemble planets and asteroids and build space colonies that orbit the star with such density that the civilization is essentially harvesting the entire radiant energy of the star. And so what you would see from Earth is a star that has a very weird, excessive infrared signature from the heat radiation given off by all of these independently orbiting space bodies. This is something, that has actually been looked for by astronomers, or that we could detect with near future telescopes. And we might not even have to look deep into space. Like, let's say we send human colonists to the moon. Maybe we find something that was left behind there by another civilization that maybe visited the solar system long ago, left something behind that we can find that we wouldn't find, from orbiters or robotic spacecraft, but you send people there and we find it. So this idea was popularized in the movie 2001: A Space Odyssey. So, if we start exploring other planets, who knows what we might find. And I mean, there could be currently active or derelict alien probes that were sent to the solar system to, especially they'd be interested in Earth, to send data back about Earth and radio it back to their home planet. And, we can't rule this out. The only way we could rule this out would be to have this vast search, or this exhaustive search of the vast, enormous expanses of interplanetary space. So I would argue that we cannot even rule out the possibility that Earth, that we're being observed right now. And I've come across this idea. I added this slide to the talk just yesterday because just a couple days ago, there was a really interesting article on the Daily Scientific American newsletter. And I can send that to you folks if you're interested. For years, very, very smart scientists have speculated that we could be living inside the computer simulation of a much more advanced civilization that essentially has near infinite computational resources. So imagine we're sort of like in the video game of a very advanced civilization. So this idea was kind of envisioned in the Matrix sci-fi trilogy. So in this Scientific American article, there's a paper that just came out that concluded, it's about a 50-50 proposition whether we're real or whether we're part of a simulation. I'm skeptical. I'm a little bit old school. I don't think this is likely, but I don't completely dismiss the possibility. So believe it or not, and this article details, there are a number of different ways that astronomers and physicists are trying to come up with ways that you could test this hypothesis about whether we're living in a simulation. But there's one very disturbing outcome. Let's say they're able to prove it, and they can prove that we're just part of a simulation. Do the simulators then decide to pull the plug? Think about that for a minute. So I just want to conclude by saying that if we are able to detect another civilization, I think that would be a really big deal. The civilization is almost certainly going to be far more advanced than we are, which would be reason for optimism that at least other civilizations can survive technological adolescence. I mean, we're on the course of destroying our planet. We've got thousands of nukes, and we're changing the composition of our planet's atmosphere. It's at such a level you can easily measure it on a yearly basis. So I don't know if we're going to make it or not. We find another civilization, somebody out there survived. Let's say it turns out they're artificial intelligence. That might indicate that we have a post-biological future that someday will merge with machines or develop AI that'll take our place. I don't know if you'd be excited by that or disturbed by that. But I think, confirming the existence of another civilization, might have really profound ramifications in ways we can't predict, especially if we can learn some detailed information about them. And even if we just detect, let's say, relatively primitive life, that would still be fascinating. It would give us insights into what types of planets and environments can support life, what kind of alternative life forms might be possible. And I would even say, let's say we build all these telescopes, explore the solar system, and we don't find anything. We go decades and don't find any extraterrestrial life. That would indicate that life might be relatively rare, which might be a good thing. It would tell us we need to take better care of the one planet where we know there is life. And maybe that would make us better stewards of our own planet. So I think no matter what we find or don't find, the search for life on other worlds is going to tell us a lot about ourselves and our place in this wondrous universe. So I want to thank all of you for listening. These are three relatively recent books that I highly recommend. I read all of them while I was researching the astronomy article, and I'll be very happy to take questions.
Wow. There's only me here on this side clapping, but that's great. I just want to say one thing, Robert. You know, I've watched the talk before too. You must have an artist living inside you because the images that you use and the way you collect them are absolutely stunning.
Well,
I know there's got to be a lot of attention to that because a lot of work went into that presentation. I really appreciate it.
Yeah, thank you. Yeah, I just want to mention I got all of those images just Google, but you're right. Like let's say you Google like life on Mars, you know, hundreds and hundreds of pictures come up, and I have to pick which one I want to use in the talk. You know, the picture has to be at least decent resolution, but I have to think this is sort of illustrating, you know, what the concept I'm trying to portray when I'm giving this information. So you're right. I'm fairly selective on what images I want to use in this presentation. And you'll notice I made a few changes from Rittenhouse from a month or so ago.
Yeah, it grows with you. It's interesting to watch it change. I want to pass it over to Brendan because he was actually texting me a question in the background. Brendan.
Okay.
Hey, I love that. That was really, I love how you covered everything from, you know, microorganisms and up to how we could discover intelligent life in the universe. I want to ask you if you're familiar with the Kardashev scale.
Yes.
It's at measuring the capacity of a civilization to utilize the energy of their planet, their sun, and of course their galaxy being type 3. Now, given that, do you think, I'd like to know what your personal opinion is on this. Do you think that an advanced intelligent civilization, possibly that of a type 3 on the scale, do you think it would be possible for them to reach our solar system?
Yeah, and that's a great question. Thank you very much for asking. And it's interesting because just a week ago, I gave a slightly earlier version of this talk to the Gloucester Area Astronomy Club in Massachusetts. In fact, just a couple days ago, they posted it online. And one of the questioners asked me about the Kardashev civilization scale. So let me just first explain to people what that is, because it's a really brilliant idea. This was an idea, I think it was like in the 60s or 70s by a Soviet astronomer. Was his name Nikolai? I think it was Nikolai Kardashev. So an idea is a type 1 civilization would be a civilization that can utilize all of the resources of its home planet. So on that scale, humans are like a 0.7. We're using a lot of our planet's energy, but not yet all of it yet. So we're not quite there to 1.0. A type 2 would be a civilization that can build Dyson spheres that can essentially harvest all the energy of its star. And then a type 3 is a galactic civilization, you know, that's spread out around the galaxy and can utilize like a lot of the energy of the entire galaxy. So when you think of all, you know, the stars and planets and black holes and neutron stars, you know, the energy of a galaxy is just enormous amount of energy. So yeah, I think you're basically asking about interstellar travel. Now, you can talk to different scientists and get radically different opinions. So I'm going to give you just my opinion, but people can agree or disagree. I'm not claiming to be right with my opinion. My opinion is that we've only had flight in our atmosphere for a little over 100 years. And yet already Yuri Milner, who I showed you earlier, has a project for sending little nano spacecraft using a laser would accelerate them with solar sails to nearby stars. So we're a very primitive civilization, and we're already coming up with ideas of how this could be done maybe in the next 100 years. So, and that's the thing, if civilizations can survive and endure for millions of years, they're going to have capabilities that are way beyond anything that like we're doing or can do right now. And especially if you're a long-lived civilization, you know, you don't even have to necessarily send biological creatures. You can just send machines like the first things we send to the stars aren't going to be human beings, or even, we're going to send robotic spacecraft, just like we've done with the planets. And we've already have the Voyagers and the Pioneers and New Horizons are leaving the solar system. Those are machines. So when you think about machines and you think about long-lived civilizations that can live for millions of years, then the light speed, the speed of light is no longer really a barrier if you have an immense amount of time at your disposal. So my view is, if there are advanced civilizations like Type 2 and certainly Type 3, I would say yes, interstellar travel will be possible. But I think you need long-lived civilizations. If civilizations burn out quickly, like we seem to be doing ourselves, then it won't happen. But if they can live a long time, yes, interstellar travel is possible. That's my opinion. If any of you disagree, I am not saying you're wrong. I could be very wrong on that.
I was thinking about your talk, Robert.
Thank you.
And I also thought about, I've said this to a lot of different kids. Did I hear you right? When we're looking at exoplanets, will somebody in the generation alive today really be able to take a picture of the surface of one of those exoplanets?
Yes. If there's a couple different ways to do it. You could do it from space, either using like a very advanced coronagraph or an interferometer, or you could build something like the ExoLife Finder. Now, it's not going to do like really super detailed imaging like you would get if you put something in orbit around Earth. It's not going to give us that kind of detailed pictures. But for example, if a world, let's say, was similar to Earth and had oceans and continents, you would be able to get like a crude image of oceans and continents on the planet. And because, of course, the planet's going to be rotating, you could observe it through many rotations as it's rotating and really build up a map and really get some information about what's on the surface. And you need to have a planet, though, that doesn't have clouds that are so thick, that like with Titan, you can't really see the surface of Titan from Earth because of that thick atmosphere. So you would need a planet, and same with Venus. You would need a planet like Earth or Mars that has a thin enough atmosphere that's not all clouds, but you could see that, and you could, observe through many rotations and get a crude map of the planet's surface. And as I said, the cities, if there's a technological civilization, the cities are going to be hot. They're giving off a lot of radiation. So yes, a civilization with telescopes not that far beyond with what we have right now could detect New York, Philadelphia, Washington, Pittsburgh from another star.
Wow. It's always been a debate with the guys up at the Hayden and the ladies who are up there too, because every time we have a new exoplanet, we have an artist rendition.
Yep.
And some of the artist renditions are beautiful, they're stunning, but some of the guys who are the scientists on the side, they say, how do you base that picture on such little tiny facts? Yep. That's why I'm kind of interested eventually if we get some type of image. And I always want to inspire younger kids who are out there thinking, how will they reach out and make a change in the universe? Imagine when we start naming them.
Let me just follow your point up about the art, Ted. So when I was living out in California in the early 2000s, I was editor of Mercury magazine, published by the Astronomical Society of the Pacific. One of my best friends there was the space artist Lynette Cook. And I guarantee you almost all of you have seen her artwork. and she was painting like when Jeff Marcy and Paul Butler would discover a new planet, she'd be the first person they would tell, and they would say, this is what we know about the planet. And she would create artwork of the planet, but all of that art she was creating was plausible, and it was all based on the information that they were telling her. This is, we don't really know if that's what the planets look like, but, it was all plausible. It was all plausible. I mean, some of these planets, we do have some pretty fairly detailed information about them, and probably a lot of the gas giants look a lot like Jupiter. Probably a lot of the Earth-sized worlds, might have some commonalities with Earth or the other inner planets. So, these artist renditions we see of exoplanets, they are based on some science. There's some speculation and some imagination, but a lot of them are going to be at least somewhat constrained by scientific fact. Does that make sense?
Interesting. Wait a second. I don't know. Henry, can you hear me out there? I don't know if you wanted to use that as a question or not. Hello, Henry, are you there? He had a good scenario. Okay, well, I don't see him turning on his mic. How about I jump over to Bill? Bill, you want to ask a last question maybe?
Yeah, sure thing. Robert, thank you for your talk. Hey, can you guys hear me there?
Yes, we can.
Okay, good. Thank you so much for your talk. The most interesting thing for me is starting to describe what is the actual signature from the perspective of Earth of extraterrestrial life on exoplanets and so on. I've read a lot about how when NASA preps their probes to go to other worlds, they do a lot of cleaning.
Yes.
They want to be very careful that microbes don't hitch a ride. But I've always been fascinated by that possibility of we're looking for life on Mars, and one day we finally find it, only to realize that it is life that came from Earth. Would you be interested in telling us a little bit about that possibility and kind of, I want to learn more about that.
Yeah, that's also, and it's interesting because when I've given this talk to other astronomy clubs, I've gotten that question. It's a very good question, and it's a highly valid concern. And NASA does take it seriously. They have, I don't remember what her name is right now, but they have what's called a planetary protection officer. And the idea is you sterilize these spacecraft before you send them to other planets. Now, my understanding is from what, interviewing scientists, is when the Viking landers were sent in the early 70s, they were pretty seriously sterilized with like heat and UV light. But my understanding is that the subsequent rovers and landers have not been sterilized to that degree.
Wow.
Because there's an assumption that, there's not life on the surface. Now that also gets into, and I don't necessarily agree with that. There's also a corollary to your question. I mentioned the sample return mission, okay, of Mars. Now, there's two scientists who were involved in that experiment on Viking that may have discovered life in 1976. The lead scientist was a gentleman named Gilbert Levin. He's still alive. He's age 97. His lead associate, who really did a lot of the work, her name is Patricia Ann Stratt. She's 73. She actually lives not far from here, right outside Baltimore. She told me, I actually interviewed her a few months ago for an article for my alumni magazine, that it's kind of crazy to return samples from Mars without really knowing what's in those samples. So in her view, we should be very seriously sterilizing everything we send to Mars, land it, look for life, really know in detail what's in the Martian, soil. And only then, if you can really rule out any kind of dangerous pathogen, only then would you return that sample to Earth. And she's like, we're talking sample return during the midst of a pandemic. Are we crazy? Now, the NASA's rebuttal would be that, and it's the case where I agree with both of them. NASA's rebuttal is that if there's life on Mars, it's undergone an independent evolution. So the odds that it could really do any harm to Earth is so close to zero. It's such an incredibly tiny risk that, we might as well do it. And I've been assured that these samples will be studied in these laboratories that are like sealed off with negative pressure, that it'll be totally safe to do it. And my guess is it will be totally safe. But I also kind of agree with Dr. Stratt that, why don't we see what's there before and really know what's there before bringing anything back? And, I think you're right. And another opinion is we should not send humans to Mars until we know that there's no life there, because you bring humans and they're going to be spreading microbes all over the place. So if there is indigenous life on Mars, it'll just be swamped out by Earth life. So there are serious scientists that say Mars should be like an ecological preserve, and we should only explore it with robotic spacecraft until we can be confident there's no life there, and then we send people. And if there is life, then we should not send people, because we can't maintain, the Mars's biosphere could be wiped out if we bring Earth and all our bacteria with us.
Boy, we've learned this lesson in the past, Robert. Remember when we came over from Europe and we wiped out the Native Americans with basically our diseases, and
That's right.
how much problems that gave. Hey,
And
I
then
want to
think
close
about
out on this
Hawaii.
one. And
Let
I
me
got,
just mention real
maybe I've
quick,
got a
Hawaii.
suggestion.
Oh, I'm sorry. Go ahead.
Go ahead. I didn't mean to interrupt you. Go ahead.
And I think about, I remember when, I've been to Hawaii several times in my life, and the tour guides say there that Hawaii, there's almost zero native life left on Hawaii. It's almost all imported life. And even here in Pennsylvania, like, what is it? The spotted lanternfly?
Yeah, right.
I mean, we have all these invasive species. I mean, in the Everglades, like snakes from Africa are destroying the native habitat there. So
well, here's a thought to close on then, Robert. And you might be the person to do it, because I know you're politically astute also. It sounds to me, and I don't think we do, we don't have anything in legislation or Congress about the Prime Directive, do we?
No. Yeah. And, because, it's sort of like, it's certainly discussed within the scientific community, but I absolutely agree. I mean, I'm not aware of like Congress or the president being particularly interested in these types of issues right now.
Well, maybe
or
to save,
even in other countries.
Maybe to save the universe from our microbes. Maybe we're close enough to that time that Star Trek becomes real, and we need a Prime Directive to guide us, in our further exploration.
I'd agree with that. Yeah, we need to take these issues very seriously, and certainly if we're going to start launching, laser propelled nano spacecraft to Alpha Centauri, we should, really think about these issues. And of course, we're already sending radio signals out into the galaxy. Now, I didn't mention this, but our brightest radio signals are not like, radio stations or TV stations. It is the military radar across northern Canada and Alaska, looking for incoming Soviet ICBMs. Though that's called the DEWS line. Those are very powerful radio signals that could be detected dozens of light years out into the galaxy, or even more. They don't really contain any information that you could learn much about the purpose behind them. But other civilizations, if they picked up those signals, they would conclude, though, that they are artificial in origin.
So we're already sending out a beacon saying, we're here, we're here.
And of course, once again, if other civilizations have their own advanced telescopes, they could detect Earth. And there's a really brilliant radio astronomer at UCLA. I think he's retired, named Ben Zuckerman. And he came up, he wrote an article when I was editor of Mercury. We later published a similar article in Sky and Telescope. Earth, every star is independently orbiting the center of the Milky Way galaxy. So all the stars are all moving with respect to one another. So he's pointed out that, during the solar system's history, our solar system has come close, within a dozen or a couple dozen light years of millions of different stars. And, even going back billions of years, Earth would have had a spectrum indicating life. Now, Earth's spectrum has changed a lot over time as the atmosphere has changed. But, even like a billion years ago, if Earth was, let's say, within 10 light years of a planet that had a technological civilization, and they had like their own version of ELF or LUVOIR, they would have taken a spectrum of Earth and said, there's life on that planet. And then, his argument is, you have an advanced civilization, you see a planet, pretty good chance there's life there. Are you just going to let that planet drift by until it's out of range? Or are you going to launch a mission and send spacecraft there, or even yourselves, to explore the planet close up? Everything we know about humans is, we want to explore, and that's what my whole talk was about tonight. So let's say one of these giant ground-based telescopes 10 years from now finds a planet 15 light years from here with a whopping oxygen signature. We then get images and it really looks like there's life on this planet. I mean, can you imagine? That's going to seriously motivate a desire to do interstellar travel and explore that planet close up. I guarantee it. That'll get people talking in a big way about taking all this very seriously.
Well, Robert, this has been an amazing night. I got to say, every time I'm with you, I enjoy this. And I fully expect within another orbit or two, you'll be producing another article. And man, I hope I can get you back again to some of these venues.
Yeah, I'm working on another article right now for Astronomy Magazine. I can't really tell you what it's about. It has nothing to do with life, though. But it's also a very interesting topic.
Well, thank you so much for sharing your expertise with us. Thanks, everybody, for tuning in from around the globe. And also, we'll be posting this on our website in the afterlife, and I know people will be looking at it there. Thanks again. This has been a talk with Robert Noya. I'm Ted Williams from Rittenhouse Astronomical Society, and we're ending our worldwide transmission from Muddy Run. Have a great night, everybody. Friends, take care.